Today's daily LeetCode problem of the day is binary search tree to greater sum tree number 1038. For this problem, we're given the root of a binary search tree, and we have to convert it to a greater tree such that every key of the original binary search tree is changed to the original key plus the sum of all the keys greater than the original key in the binary search tree. So simply all we're doing is we're taking the farmost node and we're adding as we go along, hitting the highest node before we get the lesser nodes. So we would do 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 plus 0. So my first thoughts on how to solve this problem could be a recursive method. So the recursive method would have a node value, that would be temp, and a sum value. We probably wouldn't have the sum as a recursive integer, but we would have that as a publicly shared int. I had to fix my LeetCode, something was wrong. Anyways, we would have sum as a publicly shared integer, and we want to start that at 0. So we're going to have 0 plus 8 is equal to 8, 8 plus 7 is equal to 15, 15 plus 6 is equal to 21, and so on for the rest of the nodes. So we definitely want a recursive method. We'll call it recursive. And we'll pass root as our conditions to the method. And we need to return root as well. So in our new method, let's see. What are we going to return? We're not going to really return anything. We're changing the binary search tree. So we can return void. And we're passing a tree node called temp. So first condition we want to check is temp null. If temp is null, we don't want to return anything. So if temp is equal to null, return. Then we want to go from, the way I'm going to solve the problem is I'm going to go from right to left. So we're going to start at the larger, go back towards the head node, then go to the left. Back to the head node, then go to the left, all the way to the right, back to the head node, all the way to the left. So we're going to do a pre-order transversal. Okay, so for that transversal, first we're going to want to hit the node all the way to the right. So we're going to do recursive. We're going to pass temp dot right. That will take us all the way to the right. Once it gets to 8, it'll go try to go to the next right node. It will return null, and it will come back to our node 8. So when it comes back to our node 8, what do we want to do? We want temp to equal 8 plus our sum, and sum is currently 0. So what we're going to do is we're going to do temp.val plus equals our sum. So after 8 plus 0 is equal to 8, so our new node is 8. We're going to go back to our main node because there's no nodes to the left of this. So actually here we can implement that then. So after we hit our right node, we come back to our main node, which would be 8 in this case. Then we're going to check if there's a left node. So recursive of temp.left. There's not going to be a left node for 8. But if there was, we would want our sum to be updated that 8 is now our sum. So sum is going to be equal to our temp.val. So now sum is equal to 8. So when we check for a left, there's nothing to the left. We're going to go back to 7. 7 plus 8 is 15. 7 plus 8 is 15. So now sum is equal to 15. And we're going to go back to 6. 15 plus 6 is 21. So 15 plus 6 is 21 here. Now sum is going to be equal to 21. And finally, we have a left node. So it's going to check our left node 5. 5 plus 21 is 26. That's going to be here. And 26 is our new sum. And that's going to go back to 4, to 3, to 2, to 1, to 0. So we shouldn't have to return anything as this is a void. So let's run it. Cool. So this passes our test cases. And let's submit it. Ooh, first try. So thank you, and subscribe for more daily LeetCode questions. Never mind, I decided I could do the Python solution in the same video as well. I'm relatively new to the syntax of Python, but the idea behind the code is going to be relatively the same. So I'm going to call to a recursive method that's going to use pre-order search, go to the very rightmost node, then go back to the very leftmost node, starting at the highest number, going to the lowest number, and adding them as we go along. Not exactly sure how to define a public integer in Python, but I'll work on it and see what we can do. Okay, so based on my research, it should be as simple as we'll have to use sum v, so it's not a function, is equal to 0. So that's going to be our sum value that we're going to use to add on. Then we're going to call to a recursive function, which we're going to pass our root into, and then we will return our root as well. So we're going to have to define our function recursive. We're going to pass self. Oh, wait, so no, I don't need to do that. Okay, so we'll pass self. We're going to pass temp, our root, or require temp, our root, and that's it. So if temp is equal to none, return. Otherwise, we're going to call to our recursive method, and we're going to pass temp dot right, as we want to go all the way down the right path, once again, all the way down our right path, and then work our way back. After we pass temp dot right, we should be at either our rightmost variable or whatever variable we should be working on. So temp will dot val plus equal sum v. Sum v will be equal to temp dot val. And then we could pass recursive temp dot left. And theoretically, this should pass all of our test cases. No, okay. Recursive is not defined. Let's try self dot recursive. Okay, yeah, so I think I need to use self.recursive. Maybe, not sure, honestly. Relatively new to Python. Okay. Cannot access local variable sum v or is not associated with a value. Interesting. So this does not define it as a public variable. Okay. So to access sum v, because it's a public variable, we need to use self dot in order to access it. So self dot sum v. Running this should pass our test cases. So this passes both of our test cases, and let's submit it. This passes our solution, which beats 93% of people. So thank you, and subscribe for more daily LeetCode solutions.